Hello everyone, how are you? How's everything? I hope everything is going well with you and all your families. And a very important thing is that I hope that you have had time to watch the previous video in which I introduced the transistors to you for the first time. So now, today, I'm going to continue talking about the bipolar junction transistors or BJTs. And today I'm going to explain to you what is the saturation mode. Last session, I explained for you what is the active mode, what is the cutoff mode, and what is the saturation mode. We see here that the active mode that we talked about it last session was the mode in which the emitter base junction was biased forward and collector base junction was biased in reverse. But in the saturation mode, the emitter base junction is biased in forward and collector base junction is also biased in forward. It might not make so much sense to you, which I totally understand. I'm going to explain to you what do I mean exactly. You remember this example that I had asked you to solve last session, right? In which a circuit was given to you with a transistor, NPN transistor, a resistor in the collector side and a resistor in the emitter side. And I told you the way that you go over this example is that here your base is grounded. So you know that this arrow always, whether it's here for the NPN transistors or if it was here for the PNP transistors, this arrow is working like a diode for you. So you will have a voltage drop of 0.7 here. So you could use this to figure that, okay, this VE will be minus 0.7. So you could have found the current here, and using the current that you found here and also the fact that you know that beta is 50, you can also find the current here. But this beta that I told you, it's a given value that determines the relationship between IC and IB, is only carrying this nominal value in the active mode. So the active mode of the transistor, you give a small current in the base, and this small current in the base will create a current in the collector and emitter, which is almost beta times that current. But sometimes something happens that takes this transistor into saturation. Do you remember that last session I told you there are two important parameters that we need to find always in a transistor? One of them is the IC, the current here. One of them is VCE, the voltage from C to E, which in the active mode, this voltage is always positive. VC is always bigger than VE. Okay. But imagine that there was a case that this IE was so big, okay, so big that when you had this voltage drop here, because for example, here instead of 10K, if you had 1K, then this minus 0.7 and minus 10, their voltage difference was 9.3. So instead of 0.93 milliamps, you would have had 9.3 milliamps. So this 9.3 milliamps, if you use it for IC, then the voltage VC will be 10 minus 9.3 times 5. So it will give you a negative value here. So this VCE will become negative, which is against the characteristics of the active mode of the transistor. In this situation that the transistor is suffering from this overcurrent problem, the transistor goes to the saturation mode. What is the saturation mode? Let's go over it quickly. Look, I just told you using VCE that how do we know it went to the saturation mode. Now there is another characteristic, which is VCB, the voltage between the collector and the base. Okay, so this voltage between the collector and the base is forward biased, right? So this PN junction doesn't turn on until this forward bias voltage is almost half a volt and will stay in active mode for negative VCB down to approximately minus 0.4 volt. So below that, this collector-based junction will start conducting, and the transistor will leave the active mode and goes to the saturation. So this is the situation in which beta is not the nominal value, that 50 or 100 that is given. Here you will have a forced beta. This forced beta will be IC over IB, whatever it is. The other equation, that IE is always IB plus IC, is always intact. But the beta is not the same beta. We will have a new beta. So how do we deal with this situation? We will assume that the VCE is 0.2. That's it. That's all. So let me show you the other circuit again. In this circuit, before you had figured, when you were in the active mode, you solved the problem. VC was 5.44, VE is minus 0.7, right? VCE will be like 6.14 or something, with a positive number. But with the example that I told you, that imagine this resistor was smaller and the current here was high, so the circuit was getting over current, then it would go to the saturation mode. This VCE will be negative, which is impossible. Okay, VCE is never negative. The moment that it goes below 0.2, this VCE, we say, okay, it went to the saturation. So when it goes to the saturation, we just assume VCE to be 0.2, and then we will analyze the circuit again from the scratch. This time it's easier, it's like a line. So okay, 10 minus 5 times IC minus 0.2 minus 10 times IE equals minus 10. And IB plus IE, here IB plus IC will be IE. So in this scenario now, your beta is not 50 anymore. Whatever value that you find for IC and whatever value that you find for IB, you just divide IC over IB, you will have the answer. I will solve an example for you to understand what I said, because before I solve the example, you cannot appreciate what is exactly happening here. So look at this circuit. In this circuit, you have a VCC of 10 volts, which is your power supply for this transistor circuit. There is a resistor in the collector with a value of 1K. There is a resistor in the base with a value of 10K. So we want to run the DC analysis. Here we know that the beta is 50, and we want to, of course, I always, as I said, in the DC analysis of transistor, we're looking for IC and VCE. So let's run the DC analysis. So you have one loop here, so say VBB minus VBB. Here the value of the VBB must be equal to the value of the VCC probably. Or no, actually here it's asking us to find the value of the VBB, so everything else is given. It's asking us for the circuit shown, determine the voltage VBB that results in the transistor operating in the active mode when VCE is 5, at the edge of the saturation, and deep in the saturation when beta force is 10. Okay, it's interesting. So VCE is basically given to us. So if VCE is 5 volts, so if VCE is 5 and we are in the active mode, then 10 minus 5 over 1K will give us IC, right? So 10 minus 5 over 1, IC should be 5 milliamps. So if IC is 5 milliamps, I know that beta is 50, so IB must be 5 over 50. So it's going to be 0.1 milliamps. So that's really easy. So if IB is 0.1 milliamps, VBB minus 0.1 times 10K minus 0.7 will be 0, right? So VBB should be 1.7 volts. Then we want to find VBB for the case that we are at the edge of the saturation. I just told you that for the saturation, VCE, where is VCE becomes 0.2, we're in saturation. And it cannot go below that, and we will consider it to be 0.2. So the edge of the saturation is like 0.3, right above the 0.2. So at VCE equals 0.3, we're at the edge of the saturation. It means that a bit lower will go to the saturation. So if VCE is 0.3, if you are in this you are at the edge of the saturation, if it's 0.3, so it means that your IC will be how much? 10 minus 0.3 over 1K. It's gonna be 9.7. So when we are at the edge of the saturation, we're still in the active, right? Still the beta is 50. We have not gone into the saturation, right? So you can still get the value of the IB by dividing IC over 50. And again, when you find the value of the IB, which in this case is 0.194 milliamps, then VBB is easily found again, because we have IB, so VBB minus 10 times IB minus 0.7 will be 0, right? So VBB in this case will be 2.64 volts. But the third part of the question says that find VBB when we are deep in the saturation and beta force is 10. What's the meaning of beta force is 10? It means that we only know that IE equals IC plus IB, right? But IC is not beta times IB anymore. We are in the saturation mode, and we know that in the saturation mode, VCE is always 0.2. So I know that here the value is 0.2. So can I find IC? Yes, 10 minus 0.2 over 1. It's going to be 9.8 milliamps. But now, how do I find the value of VBB? I know that beta forced now is 10. Beta forced now is determining the relationship between IC and IB. So VBB minus the value of IB will be how much? 0.98, because IC was 9.8, it's going to be 0.98. So VBB minus 0.98 times 10 minus 0.7 will be 0. So in this case, VBB will be 10.5 volts. So now look at this problem in a different way. Imagine in this problem, VBB was given to you. For example, VBB was 10 volts. Then it was asking you that analyze the circuit. So I just start to tell you how it works. You complete it for me at home. So if VBB was 10, VCC is also 10. Okay. Imagine we don't even know is it in active mode or it's in saturation or no, it's in cutoff. So are the information that we have enough? VBB is 10 volts. So I simply can run one loop here, right? 10 volts minus IB times 10. So 10 volts minus 10 IB minus 0.7 for this equals 0. So luckily we don't have any resistor in the emitter, so our equation is very simple. So 10 minus 10 IB minus 0.7 equals 0. So IB will be 10 minus 0.7 over 10, right? It's like 9.3 over 10, it's going to be 0.93. So if this is the case, we also know that beta is 50. So beta is 50. It means IC will be like 0.93 times 50. So it's going to be like 4.65. So then if this is the case, 4.60, right? Or no, times 50, because it's 0.93, so it's going to be 46.5. 46.5. Wow. So if this is the case, then 10, if you want to find IC, we'll say 10 minus 46.5 times 1 minus VCE equals 0. So of course VCE will be minus 36.5. It's not possible, is it? No. So we must be in, when we see VCE is negative, it means that you are in the saturation mode. So we say, okay, stop, we're in the saturation. We're gonna resolve the problem while we consider VCE is 0.2. So now we say, okay, now I know this is 0.2 because I'm in saturation. Then you will find IC the way that you did it here. It's going to be 10 minus 0.2 over 1, then your IC will be 9.8. Now in this case, you can find the beta force yourselves, because now you have VBB. I told you VBB is 10 as well, right? So you will tell yourself, okay, then now 10 minus 10 IB minus 0.7 will be 0. So 10, then IB will be how much? 10 minus 0.7 over 10 is going to be 0.93. How much was IC? It was 9.8. So your beta force will be 9.8 over 0.93. So I just told you the solution all the way. So I want you to solve it, bring it on the paper, and tell me what is the beta force in this case. So first of all, imagine the circuit is given to you, with VBB is given to you to be equal to 10. So you have to do DC analysis. That's it. So when you do DC analysis, you will have two different scenarios. Either you are in active mode or you are in the saturation. You will assume that you are in active always. You assume you're in active and you will try to find IC and VCE. If VCE turned out to be positive, then it means that your assumption was correct and you're in the active mode, safe and sound. So you will find IC, VCE, DC analysis, done. If your VCE turned out to be negative, it means that your assumption was wrong. So you are not in the active mode, you are in the saturation. You will say, okay, we're sorry, VCE is a known value now. VCE is 0.2. So I'm going to redo the problem, redo the solution. So now I assume this is 0.2. then I will find IC again. Then in the situation that you are in the saturation, what you need to find is IC and beta force. So in the active mode, you have to find IC and VCE. In saturation, you have to find IC and the beta force. So please solve this problem the way that I told you, and also go over lecture 20 once again and solve this example that is mentioned over there. There are other examples in the active mode as well. And come up with your questions to the class tomorrow. Thank you very much. Have fun. Take care, and I'll see you soon.